Hello, this is Professor Gibson, and this is part 2 of a video on Chapter 8, Section 1. Okay, so we've got one more of these questions to do, a hypothesis test for comparing two means. And let's get going. So, the question here is, a credit card watchdog group claims that there is a difference. So there is a difference. So this, we haven't seen that phrase before. All is a difference means, though, is that they're not equal, right? They're not equal to. In the mean credit card debts of households in California and Florida, the results of a random survey of 250 households from each state are shown at the left. Okay, again, it's actually shown below. The two samples were independent, assumes standard deviation 1 is $960. That one's for California, and standard deviation 2 is $845. That one's for Florida. Use level significance of 0.05%. All right, so looking at our first step, we have to talk about hypotheses, right? So the claim was a not equal to. That makes it so, what that means is mean 1 is not equal to mean 2, right? That makes that the alternative, because it does not include equality. So then the null is going to be the complement of not equal to, which is equal to. All right, so here's our claim. Matches the alternative this time. All right, little reminder about what we're going to do on the calculator, okay? So you're going to kick all this stuff into the calculator. Let's pull it up. Pull it over to the right here. Oh, why did it stay? Let's try that again. Doesn't seem to want to stay this time. Interesting. There we go. All right. Clear it. Okay, so we click Stat. We arrow to the right twice for tests. We arrow down to line 3, 2 samples z-test. Okay, select Enter. Now, they told us here standard deviation 1 is 960. We can hit Enter. Standard deviation 2 is 845. Just reading these right out of the question, right? Hit Enter. Now notice it was already in stats, so I left it there, okay? Stats means they're just gonna enter, they're gonna give us the statistics. If they actually give you the data values, you could hit data. So, mean of sample 1 is 3,060. Sample size for sample 1 is 250. Mean of sample 2 is 2,910. Sample size is 250. The sizes can be the same or different. If you're running the experiment, it's actually a little bit better. Your data is a little cleaner if you run them the same, but it's not necessary at all. All right, now we have to pick what is the alternative hypothesis. Remember, it was not equal to, so I've highlighted that. I'll pick Enter. Then we'll come down again. Come down a couple times, then click Calculate. All right, so we have our, this gives us our test statistic and our p-value. Test statistic, p-value, and they were, so the test statistic is 1.854, p-value is 0.637. All right, so what have we done? All right, we found our two hypotheses. We noticed it was left-tailed. We found our test statistic, and we found our p-value. Okay. Some of these will ask for rejection region, so I'm going to go ahead and do that here. All right, so the rejection region method. Now, the thing about these is at this point, because we're using the calculator, it flat out tells us the p-value. That does make things a little easier for us. But, you know, they're not always going to do the easy way for us. Sometimes they're going to go ahead and ask for the rejection region. Oh, as a side note, before I do the rejection region, you'll notice, so what I've done right down here, right, I wrote the formal standardized test statistic out. I plugged all the numbers in. For those of you that are using Excel, so you can't use this calculator shortcut, here's how you would plug that in right here. Okay, here's how you would plug that in. Okay. All right. Now, if we want to do the rejection region, remember it's two-tailed. Okay. We've got our test statistic is positive, right? Z equals 1.854. Okay. Actually, well, that doesn't really matter for this. So we've got two-tailed. That means we're going to want plus and minus. So we'll do I and V norm. You know what? I'm blanking out. What was the test? What was the level of significance is 0.05. All right. I and V norm. You notice in the I and V for two-tailed, you put an alpha over 2. So 0.05 over 2, 0, 1. All right. So let's plug that in. And remember, it's two-tailed, right? It's two-tailed, so we want the plus and the minus. So we get minus 1.96 and positive 1.96. Okay. So the rejection region, remember, is going to be further away from 0, right? So what the rejection region will be is Z less than negative 1.96 or Z greater than positive 1.96. So if our test statistic falls into either this region or that, we'll reject it. But we know that our test statistic, right, so there's our rejection regions. Now we make our decision about the null. Our test statistic was 1.854. It's real close to this one, right? It's close, but not quite. It's actually between those. It's not in either rejection region. It's in the middle. So we're going to fail to reject the null. And remember, the claim this time matched the alternative. So since we failed to reject the null, the answer for the claim, right, we have failed to reject the null, so we're kind of more or less supporting the null, I guess, right? Or at least we're saying, look, we can't reject it, so we're stuck on the null. We're more positive about the null, I guess. So what you say is there's not enough evidence to support the claim. Had we rejected the null, then this would have been there is enough evidence to support the claim. But because we failed to reject it and the claim matches the alternative, that means there's not enough evidence to support the claim. That's it for this one. I hope you find this helpful.